Jai Hind all. Myself, Dr. Amita Asthana, Associate Professor, EC Department, AKGC Ghaziabad. Now, in this video lecture, I will discuss few important questions for your university AKTU examinations. So, we will start from, let's say, a very important question, that is N-channel depletion type MOSFET. AKTU sometimes ask MOSFET questions. So, it is very important to know how you have to answer such questions because these questions are critical and they are asked to explain and the working, the concept of particular MOSFET. You don't have to write a long story about that. You just make it, some key points are there. You should mention those key points, and heading wise explanation is required always. So here, let's say a question comes like explain the N-channel depletion type MOSFET. So what you can do is, first of all, you put a heading like basic construction and symbol. So since it's a depletion type MOSFET, and you will show all these, the drain terminal, the source terminal, this is the drain terminal, this is the source terminal, and this is the substrate terminal, right? And because it is a depletion type MOSFET, so here one N channel is depleted between N type source and N type drain, right? So you have to mention these three terminals and this particular gate terminal. And we all know this MOSFET and FETs are voltage controlled devices. So if these are the voltage controlled devices, then we have to mention why these are the voltage control device. So you have to answer in this particular way. First of all, you will write basic construction and symbol, and then you will mention there is no direct electrical connection between the gate terminal and the channel of a MOSFET. You can see one SiO2 layer is, this is the SiO2 layer, and insulation has been provided between the gate and the channel, particular channel area, right? So after explaining this point, you just write the exact points, because no story writing should be there, right? The gate terminal and the channel of the MOSFET, and then you will mention that is the insulating layer of SiO2 in the MOSFET that accounts for the very desirable high input impedance. We know the MOSFETs are very high input impedance devices. So you mentioned this point, why the input impedance is very high, because there is one SiO2 layer between the gate and the channel of the MOSFET. So if it is if it is it has been asked like explain the P channel depletion devices. So what you have to do, this you will make at the drain to be P and this source to be P, and then the area, the channel between drain and source will be also the P type substrate. See, this is the substrate, and now we will make the symbol diagram, right? You have to have mentioned the symbol while you are explaining. Once the construction part is over, the important points have been covered, then you will you will make the symbol, right? You will make this symbol. Here you will make this gate. This is the drain above terminal, the source at the lower terminal, and here, see, this is combined with each other. So, and since this is N type, the arrow would be inside the gate, right? So this arrow would be like this, okay? Now, so we will now, after explaining the construction and the important points, we will see the basic operation and the characteristics. So how we will go like. So the gate voltage is, see, first of all, see, always remember whenever it is N channel, N type, okay, VDS is always greater than 0. So first case you will make VDS to be greater than 0, some positive value, and VGS to be equal to 0 volts, right? the gate voltage is 0 and the source is at negative potential. So we are mentioning that gate voltage, we are giving no voltage here. See, the gate and source has been shorted. So they have been shorted. So there is no voltage between gate and source terminal. So we will mention this as VGS to be equal to 0. So, and then hence electrons of the N channel. So because this, see, this drain is at positive terminal and this source is at negative terminal. See here. So this, since this is a negative terminal, so electrons will be repelled from this negative terminal and they will go upwards to, and they will start collecting towards the drain region, because the channel is also present. So electron can move very easily from source to drain. You need to explain this particular point, right? So we will see, due to electron flow, because electrons are flowing from source to drain, so there would be a current in the reverse direction from drain to source, right? So this is how you will show this current. And obviously we have, we have current coming out from the positive terminal of the VDS, right? Now we will explain case number 2. After explaining case number 1, we will explain case number 2. Now we will apply some voltage at the gate terminal. Here, since VDS is greater than 0, I told you VDS for N channel, it is always greater than 0 for N channel, right? Always remember this particular point. Then VGS will be opposite of it. In the second case, VGS and VDS will reverse each other, right? So we will make the case VGS to be less than 0. So we will apply the negative voltage at the gate terminal, right? And when the negative voltage is applied, now what, since this gate terminal is at negative voltage, the electron will repel from this gate terminal, right? And they will start, some of the electrons will, since this is the p-type substrate, so there are plenty of holes. The electrons will recombine with this holes, and you will explain this in this particular case, right? Now, after explaining the case number 2, case 1 and case 2 are over. Now we will write the Shockley's equation. You must write Shockley's equation. ID is equal to IDSS 1 minus VGS upon VP square. Now, what is VP here? Okay, now I will explain each term. ID we have seen right here. This was my ID, IDSS, IDS or ID, drain current. This ID I am mentioning here as ID. Whatever the case is, whatever the voltage VDS is, the current will be termed as ID, drain current. Now, IDSS is the current when, for the case 1. See, here I will put VDS and ID. So we are applying a positive voltage of VDS because it is N channel. Current will increase and then it will be saturated. And this, what I am talking for, VGS is equal to 0 volt case. When the current gets saturated, this particular point is known as IDSS, right? This particular point is known as IDSS. Now, see here, so we have this IDSS, and now what we can do is, see, VGS upon VP square. What is VP here? At current IDSS, we have voltage to be termed as VP. So you will explain for VGS is equal to 0 volts, right? Now, here, this particular graph which I have shown, this is VGS is equal to 0 volt. This is IDSS, and this particular voltage is known as VP, right? And now, if I increase VGS to be positive voltage, this current will increase. But if I am applying a negative voltage, the pinch off will decrease, the current will get saturated at negative, more negative values more early, right? So this particular graph explains the behavior of n-channel MOSFET for VDS and ID. So this is the relationship between ID and VDS, and this particular the formula which I have written here, the Shockley's equation. Shockley's equation is given by this particular curve, and this is known as the transfer curve. So you can see in this, if I made this VGS to be equal to 0, let's say, okay, then this will be what? ID is equal to IDSS, which I have mentioned here. ID is nothing but IDSS at VGS is equal to 0 volt. See the graph between VGS and ID. So when this, ID is 0, VGS, if VGS is equal to VP, then ID is equal to 0, this point, okay. And similarly, if ID is equal to 0, that means VGS is equal to VP. So here we can mention this particular point, VGS is equal to VP. So here we can make this graph. Now we will, after explaining this particular, network, we will do one more important question. So this is the question. Determine and draw the output voltage of the given network. Right? So now we will do this important question. This is a clipper question. This is a clipper question. And here we are given a triangular waveform, you can see. The peak voltage is at 16 volts. And now this diode is ideal. This diode is ideal. This is a 4 volt voltage. This 4 volt is making it forward bias, right? And when this particular waveform is at positive, after 4 volts, between 4 and 16, this diode is getting reversed by this particular waveform. So there would be two cases, first case and second case, case 1 and case 2. Always remember that you need to solve a clipper question by making the cases, case 1 and case 2, right? So case 1 would be the 4 to when the Vi is greater than 4 volts and when the input waveform is below the 4 volt, right? So we will solve this particular question. Okay, so this is how we have one resistance R. The diode is open. Here it is 4 volt. And the output. Since this is open circuit, there would be no current in the circuit. So we can say VO is equal to, right? Now coming to the case 2. When Vi is less than equal to, so you will make this circuit. The diode is short. Okay. Now VO would be what? 4 volt. This is 4 volt because between these 2 points, if I see the voltage is 4 volts, so VO is equal to 4 volt. Now what we have to do, we have made the cases, we have calculated the output voltage, and the question is asking determine and draw the output voltage of the given network. So we have solved this question. In case 1, we made the circuit, found out the output voltage. Then we, in the case 2, we found the output voltage. So now we will make the waveform, because always remember that you need to make the waveform, right? So here I will make it waveform. Draw a rough sketch of input voltage. This is 16. Mention your 4 volt point. Slowly you need to work on. Don't be in so hurry, otherwise you will make the waveform wrongly. So here for 4 volt, this VO was above 4 volt, VO is equal to VI, right? Above 4 volt. And less than 4 volt, for this particular part of the waveform, the voltage is constant. And this is the answer. Okay, this graph is for output voltage, and this is at x-axis. Always mention the axis, make the waveform correctly, and then you can proceed in this way. So here there are 2 questions we have discussed, and these 2 questions are very, very important. Whether MOSFET comes out in the question or a clipper comes out in the question, always remember that you have to explain, you have to answer in a very, very refined manner. Yeah, okay, let's say we will discuss one more question here. So now determine the range of input voltage Vi. Now we are going to discuss one Zener diode question. Vi for the Zener diode to remain in on state, showing following figure. Figure has been given. Vz is 20 volt. You can see Iz maximum is given 50 milliampere and Rz 0 ohms. That means they are saying that you can ignore the Zener diode resistance. Now we will. This is the circuit what they have given in the question. So here in this question, Vz is equal to what? See, Vz is 20 volts. So we will write okay, and they have given Iz maximum 50 milliampere. We will write for our convenience. And now they are asking for Vi minimum and Vi maximum. These 2 questions. That means this is a case 3 question. Oh, Zener. Right? Case 3 of Zener diode. So case 3, we have to find out Vi minimum. So the formula we will apply. Okay, this is the first formula, and we have given Vz 20. This is 250 and this is 2000. Put the value and you can find out the value of Vi minimum. You can find out because all these values are known. Just simply you can put this and you can find out the value of Vi minimum. Now next part. Now what you have to do is you will just make it figure, and now you will turn the Zener diode to be on. Make it on. Okay. And this is now 20 volt. Always remember this side should be, upper side should be positive. Okay. So here make it Vi max. And this current, take it as, why Vi maximum? Because it is very, very clear that whenever the voltage is at its input voltage at maximum, then input current will be maximum. This is 20 volts. Here IR max, this is fixed, constant, because this is 20 upon 2 into 10 to the power 3. Okay. So this is IL. Okay. What we have calculated, this is IL. Now you can apply this formula. RL maximum is equal to IZ. IZ plus IL. Since this is fixed, so this will be maximum. To balance this equation, IR maximum is equal to IZ maximum plus IL, right? So now we have already calculated this, IL, and IL is this thing, 20 upon 2000. And now we will apply Kirchhoff voltage law in this particular loop and write the equation Vi maximum plus, make it as positive, this is minus IR maximum into 250 minus 20 is equal to 0. So this is second equation, this is first equation, and by solving these two equations you can readily get the answer. So we have discussed one Zener diode question, one Clipper question, and one MOSFET. We'll see whether it is a theory question, it is a MOSFET question, or it is whatever it is. You have to straight give the answers so that you require minimum time and you get maximum marks. Thank you.